Good afternoon or evening, depending on where you are, and welcome to the fifth webinar of the webinar series, Future of Geotechnical Education at the University Level. Those who couldn't attend our previous webinars, please check our YouTube channel to watch the recordings. Before we start, I just wanted to let you know that this event is being recorded, and please bear with us if there is any technical difficulty. So my name is Shama Roy, and I'm the Vice Chair of the Canadian Geotechnical Society Education Committee. The mandate of the Education Committee is to identify and address issues and problems concerning all aspects of the continuing education of our society members. The Education Committee is also concerned with the involvement of students in the society, as well as geotechnical education at the Canadian universities. We thank to the Canadian Geotechnical Society for supporting this series. As usual, we always start with a safety moment, and our today's safety moment is be safe by the water. As you know, like the summer, we are already in summer, and many of us enjoy water activities such as boating and swimming. But unfortunately, each year, tragic and avoidable water-related fatalities occur across Canada. So for a very important point to keep in mind, active supervision, diving, pets, and open water. So provide life jackets to non-swimmers to keep them at the surface to assist while you are supervising. Whether it's a pool or a bathtub, a water park, or the beach, always watch children actively around water, even if they can't swim. Diving headfirst into the water should be avoided unless the individual is properly trained and is sure that the water is deep enough. Also, pets can drown, so limit swim time and provide an easy exit from the water. And never underestimate the power of current. Be cautious about swimming in currents and know what to do if you're caught in a current. So if you want to know more, there's a link there and you can go there and get some really good safety moments for being safe by the water. So before we get started, I want to say a quick thank you note to our sponsor, Northern Crescent Incorporation, who is the sole sponsor of this webinar series. Northern Crescent is a multidisciplinary engineering firm serving all phases of project delivery. Their journey began in 2010 with a focused vision to provide engineering services to a wide range of clients. Having built a solid reputation, their industrial base now broadened to include multidisciplinary engineering, including geotechnical engineering, support for the oil and gas facilities, chemical plants, fertilizer plants, industrial and residential buildings. They have a strong R&D team who are collaborating with several universities on very interesting geotechnical projects. One of the interesting outcomes from these R&D projects are the in-house tools or software, which you can check on their website. As you can see in the screen, so these are like 6 softwares or tools that they have built, and these are the outcomes from the R&D projects that they're doing. So thank you, Northern Crescent, for your generous offer. Just a quick housekeeping items. So we are on YouTube. Till to date, we have 245 subscribers with almost 3,500 views to date. And again, this event is being recorded and the recording will be uploaded to our YouTube channel. A PDF copy of the presentation slides will also be made available to the attendees upon request. So if you really need the presentation slides, please reach out to me or Dr. Yu directly. If you have any questions regarding the talk, there will be a short moderated question answer after the talk. So please type your questions into the chat box and we'll try to address all the questions to Dr. Yu. With that, just a brief introduction about Dr. Yu. So Dr. Yu is an assistant professor in the Department of Geography at the University of Tennessee, Knoxville. His broad research interests include geographic information science, which is popularly known as GIS, remote sensing, and open source software development. Dr. Yu is a strong advocate of open science and reproducible research. He has developed various open source packages for advanced geospatial analysis. For example, GMAP, LeafMap, and Whitebox tools front ends, which are available on GitHub. So more information about his research can be found on his personal website and YouTube channel. So I personally got benefited by watching the videos that Dr. Yu uploaded in his channels, especially YouTube channels and the website and LinkedIn as well. So I'm pretty sure this is going to be an exciting presentation for all of you. So without further ado, Dr. Yu, the stage is yours.
Thank you, Sama, for the introduction. Let me see. Looks like I have some echo. Let me see here. Can you hear me?
Yes.
Yes. Okay. Let me maximize my screen. Is it look okay?
Yeah, all good.
Okay. Thank you very much, Swama, for the invitation and also the introduction. I'm very honored to present this talk today. The title of my presentation is Interactive Mapping and Geospatial Analysis in the Cloud using Open Source GIS. The slide for my presentation can be accessed by scanning the QR code at the lower right corner, or you can go to the URL gshub.org and then CGS. I also send the link in the chat box, so you're welcome to click the link to follow through the presentation. And so the idea is that for this presentation, I'm trying to give you some options using some open source software packages, how you can utilize that. And all you need is just a web browser. You don't need a fancy computer. You don't need a powerful computer, but you can still do a lot of interesting things. Oops. So it looks like I'm... Can you still see my PowerPoint?
Yeah, I can see you, Ricky.
But right now, I'm not seeing my PowerPoint. Let me see here. Okay. And so here is the outline of my presentation. I will first briefly introduce Google Earth Engine, and then I will focus on GMap and DeepMap, the two packages that I developed. I will also introduce white box tools that I also here. The white box tools that I also contributed to a couple of front ends. So I will also introduce that. At the end, I will show you some additional resources if you want to learn more about my work. And lastly, hopefully we have some time for questions and answers. On the right here is an animation that created using GMap. So if you want to try it out, you can go to the URL here, timelapse.gmap.org, and you will be able to create something like this. So this can be created within just a couple of seconds, and you will be able to create animation. You can also extract, for example, surface water, vegetation, or urban area, whatever you need. And it's just quick and easy. So here is a quick animation. Here you can see how it works. So all you need to do is just go to the URL, and then you can search any location you are interested in, or you can just zoom in and zoom out to a location. And after that, you just need to select some parameters. For example, what kind of a satellite you want, and what's the start year and also the end year. You can also customize the band combination. So using remote sensing, we have a lot of options how you can use band combination. And then you can change the color. You can also use some different water index or vegetation index if you want. And this is something you can create just within a couple of seconds. And then you can also download the animation to your computer so that you can share with other people. Next, I'm going to quickly show you some examples. So for example, on the left here is the ROC. And you can see the striking shrinking of the water body. On the right here is the mining in Alberta, Canada. So this might also be relevant to the Canadian Geotechnical Society if you're interested in. Also coastal expansion, for example, in Dubai, and the river dynamics in South America. Also deforestation in the Amazon. I also landslides in Peru. You can see this one actually lasts for decades, right? So this is a large landslide. You might not be able to identify that in the ground because it's very slow, but if you look at the longer time series, you can see the dramatic changes. You can also look at urban growth, just like here in Las Vegas, right? And you can see the urban growth. You can see also on the right here, the reservoir, the shrinking of the reservoir. Similarly, you can use that to examine urban growth in any other location. So this is another example in Dongguan City in China. So this just give you some example. You are welcome to check out the website to play with all the parameters and to create animation like this for your region of interest. So behind the scene, those animation were created using the Google Earth Engine cloud computing. And for those of you who are not familiar with Google Earth Engine, I'm going to quickly, briefly introduce you. So Google Earth Engine is different from Google Earth. Okay, so Google Earth and Google Map are something that you can, just like a virtual globe, you can use to see satellite imagery, you can navigate, but you cannot do any analysis. So it's just basically a base map. And Google Earth Engine basically is a computing engine behind Google Earth. So you can use that to do a lot of powerful analysis using those available satellite imagery or other geospatial data set. So this is kind of a simple analysis. Is that Google is just like an image viewer, for example, on Windows computer. Google Earth Engine just like a Photoshop. You can do all kind of fancy and powerful things. And I'm going to show you some examples shortly. Google Earth Engine is free for research, education, and non-profit. So you're welcome to go to the website to sign up. Upper right corner here, click the link, and then you can sign up. Sometimes it might take a couple of days to get approval, but once you get approved, then you can start using enjoying the cloud computing of Google Earth Engine. And so before I get into the details about Google Earth Engine, I want to give you a quick analogy. Why do we want to use Google Earth Engine or some other cloud computing? Because besides Google Earth Engine, right now we also have a Microsoft Planetary computer. So those are all very similar. They are all cloud computing platforms. And compared to a desktop computer, what's the advantage of using cloud computing? So here is an analogy, right? In the old days, if you're trying to watch a movie, for example, you need to buy the DVD, right? And then the DVD might take a couple of days to send to your home. And then you need to open a DVD, and then you make sure that you have a DVD-ROM on your computer so that you can open the DVD and then you can start watching the movie. Nowadays, if you look at all kind of streaming services, for example, Netflix, Amazon Prime, and also Disney Plus, right? So nowadays, you no longer need to buy the DVD, no need to buy a Blu-ray. You can just go online, and then you can just need a browser, then you can watch movies, right? And very similar in a way that traditional remote sensing using desktop computing. First, you need to get the data. So assume that the DVD is similar to the data set. So you need to, for example, go to different agency or different website to download the data. It's just like you go to different store to buy the DVD. And then once you have the data, you need to make sure that you have some software or computer. For example, you need to have a computer to open the data, and then you need some, for example, ArcGIS or ENVI or other, whatever software you're using to handle this. But you also need to have a powerful computer if you're dealing with large scale data. But nowadays, you just need a browser. You can use Google Earth Engine or other cloud computing, and you don't need a fancy computer. You can do that even on your iPad or your cell phone. So this is basically advantage, and you don't need to worry about the data storage, right? So in the past, if you need to copy the DVD to your computer, if you are dealing with a large area, you might need terabytes of data storage in order to do computation. But now you don't need to worry about that. You just need a browser. That's it. So that's the huge advantage of using cloud computing. So either it's Google's Engine or some other cloud service provider. So just to give you an idea why it is useful. So one very simple example is Google's Engine you can use to create cloud-free imagery. So keep that in mind. At any time during the day, the Earth is covered maybe 60–70% by cloud. So cloud is a huge problem for remote sensing. And if for Landsat data, every year you might, for example, every location, you might get 30–40 images, right? But there'll always be cloud in some images. And one thing you can use Google's Engine to do is to create cloud-free images, just a few lines of code just like this. So it's just like magic. And if you use Google Earth to look at satellite imagery, you might notice that, you rarely see the cloud. It looks perfect, but keep that in mind, those imagery might not be real original imagery because some of those have been processed using Google's Engine. And the idea is very simple. Every location, you have 30–40 pixels. You pick the base pixel. And then, so when you put them all together, you get a nice imagery. But every pixel might come from a different date. So, for example, in this nice imagery you see from here, they're not taken at the same date. It's basically multiple days or multiple years in order to create this kind of mosaic. And you only need a few lines of code you can create like this. And Google's Engine has a huge data catalog. Right now, it's more than, I think maybe it's 40 petabyte right now. So 1 petabyte is 1,000 terabyte. Keep that in mind. If you're trying to deal with this kind of data on your computer, it's not possible. And the data set is growing every day. It has Landsat, Sentinel, pretty much all the common satellite sensors. You want to find data in the data archive, you can go to the EUIL to explore, and they are logged about terrain, land use, land cover, you name it. If there's a data set you want to use not available in the data catalog, you are welcome to upload data to your own personal account. You have 250 gigabyte that you can utilize. So still a decent amount of data storage you can utilize to do cloud computing. Google Earth Engine provide, I think right now, 3 languages API. So JavaScript, Python, and also the REST API. So JavaScript is probably the most commonly used one. You can go to the URL to try it out. And so this is not the focus of my talk today. My talk is basically about the Python API. So why do we want to use the Python API compared to the JavaScript, right? So Python is very popular, and it has a lot of editors. You have a lot of open source packages that you can utilize, and you can also integrate with other open source software, for example, QGIS and others. You can also do deep learning. Also, you can access data locally. If you're using the JavaScript API, you are limited to the browser. You cannot communicate with your local computer pretty much. So Python API is very, very useful, but there's something like in the Python API. So the Google Earth Engine official Python API mostly just for doing computation. It doesn't provide functionality for you to visualize the data set interactively, how to retrieve the data. So it's not very convenient. So this is basically right now I'm showing here is the JavaScript API interface, right? So you might be able to see the map here. On the right, basically is the identifier. When you click a pixel, you can get the pixel values. On the left, you also have all kind of documentation. But for the JavaScript API, you don't have this. And that's why I developed the GMap Python package to actually to fill the gap. So that allows you to not only do computation, but you can also use the interactive user interface to source the data set, to create with the data set, to visualize the data set very, very easily. And so then now next, let's get into the GMap. So what exactly is GMap? It's basically just a Python package for doing interactive mapping and analysis with Google Earth Engine. So the computing backend is relies on Google Earth Engine, but the front end, you can do interactive mapping. You can create some interactive plots, for example, using IPyLeaflet and IPyWidget. Everything is open source, so you can go to the GitHub website to look at the source code if you're interested in. And it has been widely used by the Google Earth Engine community. It can run on Google Colab, also on Jupyter. So those are the 2 primary platforms you're going to utilize if you want to try out GMap. And so you can install using pip or conda. So the 2 common ways you can install Python packages. I also have tutorials showing you how to install. If you want to look at that, you can click. I'm going to show you more videos later. And it's also very easy to update the package. So the package is still being actively developed. So I might add some features daily or weekly. And you can always enjoy the new features versus running this line gmap.update package to get the latest features. And so as I mentioned, you can run it on Google Colab or run it on Jupyter. So for the Google Colab, all you need is just a browser. So for example, you can just click this link here, and then you will open your Google Colab, or make sure that you have your Google Earth Engine account approved before you can use. Otherwise, you won't be able to access Google Earth Engine. And on the left here shows you some example how you can utilize that. So Google Earth Engine on Google Colab, it's going to use the Folium protein backend. So Folium is another interactive mapping library. It has relatively interactive functionality. So just want you to be aware, if you're using Google Colab, you can create some maps, but you cannot really utilize the toolbar that I developed. So it's mostly just for creating some final output that you can use. If you really want to enjoy the power of GMap, I highly recommend that you install Jupyter on your local computer and then install the package. Then you can follow the tutorial to do some nice visualization of Google Earth Engine dataset. If you like, you can also try out the binder, but they basically just need a browser. But this is not a recommended way because you need to authenticate Google Earth Engine to do computing. So it might save your token on the public instance. So it's not the recommended way. But if you don't care, then go for it. So it highly recommend that you just install the package on your computer, and then you just need to authenticate once. And after that, things get very easy. You can also go to the website, so very easy to remember, gmap.org. So that's the website. You have all the documentation. You can also look at how to get started. I also have a bunch of tutorial showing you how to use Gmap. You can also look at all the functions, all the APIs. So for each function, because it's open source, you're welcome to click the source code if you want to learn more about how this package was developed. So I think I started this one August 2020, right after the pandemic. So, and I've been adding features to the package basically weekly or daily. And you're welcome to look at the source code, see how it was developed. And I also welcome a contribution if you want to contribute something to the package. Also, if you enjoy the package, if you find it useful, I would appreciate that you can cite this paper. So it was published last year in the Journal of Open Source Software. So you can check out the paper. Next, I'm going to show you some of the tutorial available for using Gmap. You can check out my YouTube channel. So I published a lot of video during the past year, and specifically for using Gmap, you can look at here. I already here has 60 videos. 16 hours. So for each new feature, key feature that I develop, I have a video associated with the notebook so that you can follow through if you want, if you have time. And so right now the YouTube channel has over 8,000 subscribers and almost 250,000 views. So just for the past year. So I appreciate all the support from the geospatial community. So you're welcome to check out the video. And like I mentioned, I have over 60, but for the notebook example, it has over 100. So right now I'm kind of behind my schedule to record the video, but you can go to the gmap.org to look at all the notebook examples if you want. And here is a kind of a list, a short list. So I have 58 here. And for each video, each tutorial, you can see a video. So the full length video usually is 15 to 20 minutes. You also have a GIF animation, so it might be a short video, just 20, 30 seconds. But also you can look at the source code, so you can follow exactly how the tutorial was developed. And this makes things fully reproducible. So my goal is to make things reproducible and replicable. So everyone will be able to reproduce exactly what I did in those videos. And so you're welcome to check out the list. A couple months, I think in April, I also presented a workshop. It's 90 minutes at the GeoPython conference. And that video also introduced all the key features of Gmap. If you're interested in, you can watch the video. Next, I'm going to show you some of the key features. Just to give you an overview, I'm not going to get into the detail of each individual feature. There's just too many to introduce in here. But I want to give you kind of overview that think about how Gmap can be useful in your research or in your teaching. Just kind of an overview. It's good to know at least like what you can do, and then later if you want to learn more, you can come back to the video to learn more. So the first one here is to automatically convert Google Earth Engine JavaScript to Python. If you're already a Google Earth Engine user and you are using JavaScript a lot, then you might enjoy this feature if you want to switch to Python. To be integrated with other workflows. So all you need to do is just to copy the script and then open the interface. You just paste and then just click one button. And then it will automatically generate the source code Python API. Then you just run one button. So basically you don't need to do any coding to do the conversion. You can also search the data catalog. As I mentioned earlier, Google Earth Engine has over 35 petabytes of data. You can just type any keywords you want, and then you search the data set, and then just click the import button, and then you can just directly load the data to the map without having to download anything. So you have access to the entire Google Earth Engine catalog just with a few clicks, and you can customize the source code if you want. But this gives you a way that you won't be able to do using the raw Python API because you cannot visualize the data. And again, so each video here shows you the full length, the links to the video, the animation, and also the notebook. So you're welcome to check out. You can also change the layer visualization. For example, opacity. You can customize what kind of spectral band combination you want to see the map. So you might be familiar with this kind of functionality in the traditional software remote sensing, for example, ArcGIS or ENVI, right? How you can do the combination of forced color composite or natural color composite. You can do this easily in GMap and no coding. So you can just need a browser. You can have access to all this functionality. You can also use the inspector. So keep in mind, everything here, all the data are stored in the cloud. So how can you basically query the data set? For example, you just want to get a pixel value of a specific pixel. You just need to activate the inspector. You click your mouse, it's going to retrieve all the data set. So this is somewhat similar to, for example, to ArcMap. You can use the identifier to identify anything. So this applies similarly here in GMap. You can also do interactive plotting. For example, you want to take a look at the spectral signature of the image. Again, just activate and then click on the mouse. Your mouse, you will be able to see the spectral signature nicely without coding. You can do that for multi-spectral data, hyperspectral data, any data. So it depends on how many spectral bands you have in the image. You can create images like this. You can also customize. This is just the default one, but you can customize the map to make it look much nicer. So everything is interactive, depending on where you click your mouse. You can also load your local data set, vector, raster data, any kind of vector data supported by GeoPandas. You don't need to do any coding. You can just use this interface to open the data, and you can also convert the data directly to Google Earth Engine objects. But keep in mind, this is designed for small data set. If you have a huge, like gigabyte data set, it's not going to work. You need to upload data to your Google Earth Engine account. But if there's a small testing data set, you can use this to quickly load your vector data, your raster data onto the map so that you can compare the data set together. Makes it very easy for you to overlay multiple data sets within the browser. And you can also visualize raster data set. As in this one, I already introduced earlier. You can change the layer opacity. You can change all kind. If you can also add a color ramp, right? So if you want to change how the map look like, you can easily change this one. And there are lots of color map you can choose from, more than 200. So those based on the Matplotlib library, and there are a lot of things you can choose. You can also apply to multi-spectral data, different band combinations. So again, very easy to do, no coding. You can also save the code. If you want to use it, reuse it later, you can just click the import button, and then you'll be able to actually keep the source code so they can reuse it later. And this is for raster. You can also do it for vector. So very easy to do. Just simply open the dataset, and then you can convert the dataset to Google Earth Engine objects, and then you can do all kinds of visualization. So you can, depends on how you want to visualize. You can visualize data depends on the attribute column, or you can change things easily using this graphical user interface. You can change the color, you can change the opacity, you can also change the outline. Again, no coding, so makes things really, really easy. If you're trying to do this one, although every feature here looks pretty simple and easy to use, but keep in mind, behind the scenes, sometimes those are more than 1,000 lines of code actually to be able to produce this. So some of those actually are very challenging to implement. For each feature, sometimes take me actually a couple of days actually to implement. It needs a lot of debugging to put all the things together, connect all the components. So it's definitely not easy to do. But hopefully, after I do the coding, you don't need to do the coding. But again, it's open source, so you're welcome to look at the source code if you want to learn how this was actually developed. You can also do machine learning. So one of the things you can, the advantage of Google Earth Engine is that you can do large-scale image analysis. For example, machine learning, image classification. So you can do supervised classification. You can do unsupervised. So a lot of common machine learning algorithms are available within the Google Earth Engine platform. So you're welcome to try it out. Also check out the notebook. This one is a bit more long, so I'm not going to get into the details. And for example, after you do the classification, you might want to visualize. So lane use, lane cover change. You want to visualize the change using some existing data set or your the data set that you develop. You can use some Sankey diagram. So it's very nice. Again, no coding. You can draw any rectangle or any shape in anywhere around the globe, and then you can just click one button to generate same Sankey diagram like this. And so this one's an earlier version. Now you can, it's much better. You can integrate that one directly within the map. So you should be able to see the changes directly within the map without having to scroll down. So again, the interface that you develop, you see here might be different from the current version because new features are being added frequently. So it might not always be the same, but you get an idea what it can do. You can also do 3D terrain visualization. For example, you have some DEM, you want to visualize the DEM in the cloud, and also some 3D. You can also do that as well. And so check out the example if you want to learn more. You can also create some publication quality maps. For example, after you do all the analysis, you want to export the map. Traditionally, you have to output the data and then import into, for example, QGIS or ArcGIS in order to create some nice quality maps. But in GMap, you can also use the Kato EE package that so that you can also create maps like this, and this will be publication ready, so you can directly use these maps in publication or technical report. And you can also publish the map. So after you develop the data set, you have the algorithm, and then you want to share this one to anyone. You can publish the map. You can also use the Google Earth Engine apps for the JavaScript, but in GMap, you just need one line of code that you can publish the map to the internet, and then you can share the link with anyone so they can see the nice data product that you generate. And I think this is the last example I'm going to show you. This is more like showing how you can use Google Earth Engine to do large scale image analysis, mostly global scale. So for example, if you want to figure out the surface water dynamic, you want to see the changes of a certain feature, you can use this example. For example, this is for surface water. So you can quickly extract the surface water area for a specific water set, right? And then you can see the changes. So it's going to plot automatically the area for this region, for this water set. And then it's going to automatically extract the water. So the blue area is the one extracted. You can also export the data set, export the summary. So you can download the data set back to your computer to do follow processing. It's not limited to just the polygon data set. You can actually draw a rectangle on the map anywhere, and then you will be able to actually to compute that for you. So this is basically scale independent, so you can do that for anywhere. You just no coding. You just go to the example, click the link, and then on the left here shows you the URL. You are welcome to export that for any region that you are interested in. And again, this is just a simple demo. It's not going to be perfect for very accurate, but you get the idea what you can do, right, about Google Earth Engine. Okay, so that's about what I want to introduce about GMap. And so as you can see, it's very powerful. You have access to the entire 35 petabyte of data catalog. You can use any data set and directly within the browser, just using your cell phone or even your laptop. And so next I'm going to introduce LeapMap, but I want to briefly talk about why I introduced LeapMap. So GMap was developed last April. LeapMap is relatively new. It was just released a month ago, so it's still quite new. But the motivation behind LeapMap is that so GMap, Google Earth Engine is free for research, education, and non-profit. But you need to buy license if you want to use it for commercial applications. And also Google Earth Engine itself, the computing engine behind is not open source. So GMap is open source, but Google Earth Engine is not. So there are still some people that have some concern about not being about closed source. And so in order to fill the gap, right? So I basically spin off the project from GMap, take out all the components that you don't need to use Google's engine. So this makes it a fully open source. So everything right now there is basically open source. So you can use that to with any cloud computing resources you have, Jupyter or any other AWS or any cloud computing resources. So it's fully open source, and you don't have to worry about commercial or personal applications. So you can use it for any purpose. And again, it's free, open source. You can check out the GitHub URL. And so as you can see from here, it just released a month ago. Right now already has more than 800 stars on GitHub. So definitely a lot of people are interested in using this. And this is more general. One thing, you don't need to worry about Google's engine authentication. You can directly use your browser to open, and then you can do all kind of cool stuff using LeafMap. And it also rely a lot on some of the open source packages, for example, IPyLeaflet Folium, and also IPyWidget. So IPyWidget is how it makes things really, really powerful and with a lot of interactive GUIs, also HereMap widget. So LeafMap has 3 protein backends. You can use IPyLeaflet, or you can use Folium, or you can use HereMap. You can choose whatever you want. And behind the scene, the geoprocessing backend is using Whitebox tools. So also Whitebox GUI, but we also utilize GeoPandas and XArray for some raster processing. So you're welcome to check out the GitHub. Again, you can install using pip or conda, and you can also update the package using leafmap.update package. And on the right here, I just starting doing the video tutorials, and right now only have 3, but I plan to add video every couple of days. So you can follow my YouTube channel to if you want to learn more about LeafMap. So here, how do you get started? All you need to do is just to click the link here. If you want to use Google Colab, click this link. You can also use a binder. So highly recommend you use the one on the right. The downside is that sometimes it might take a couple seconds or minutes to open up. But Google Colab, you can open up instantly. But as I mentioned earlier in the GMap package, Google Colab does not support IPyLeaflet due to some security reasons. I'm not sure if it will be supported in the future, but at least you can use the Folium. So you can create a map. But again, you cannot really interact with the map. You can only zoom in, you can zoom out, that's it. You cannot click your mouse and then get the coordinates and then do some other analysis. You cannot. There's no toolbar. So, but for the IPyLeaflet, everything is fully interactive. So you can enjoy all the features of LeafMap. So highly recommend. You can also install on your local computer. But if you just want to try it out, just click the link, open the web browser, then you can go through the notebook to execute the source code. Also, you can go to the leafmap.org. So this is the documentation website. And again, it's very similar to GMap. You have all the information, how to get started, how to do the tutorials. You can also look at the API documentation to learn the source code behind each function. You can also go to the notebook section for each notebook. So you can just look at those notebooks interactively on the browser. Also, if you want to cite GMap, I will appreciate. So this is right now under review. In the open source software journal. So next, I'm going to show you quickly some key features, like what LeafMap can do for you. And so the first one here is to change base map without coding. As you can see on the right here, you just click the toolbar, and then you can change the layer, you can change the opacity. You just need to click one button. So there are lots of base map you can choose from. I think maybe 50, 60 base maps. So Google Map, Esri base map, or any base map, no coding. You can do coding if you want, but I'm providing a quick way for you to switch base map. So you can also add your own base map if you want. There are a lot of things to choose from. You can also use the time slider. So this one use the Planet global monthly mosaic. So you can access to the 5-meter resolution planet imagery monthly, and you can look at the changes on Earth for any locations. But this one doesn't require the Planet API key. So you need to sign up for an account, and then all you need to do once you pass the API key to the notebook, then you should be able to simply use the time slider to visualize the changes for any location. So it doesn't matter where you are. You can use the time slider to slide through. You can also open your local data set. So if you have some vector data, Shapefile, GeoJSON, or GeoPackage, so any vector data that's supported by GeoPandas, you will be able to directly open using LeafMap. So just click the button and then change the data type, and it can automatically visualize the data on the map. So you can customize if you want. You can also see the pop-up attribute. So give you idea how easy it is to open data. If you're trying to do this using coding, sometimes it might take a couple nights code. So it's not very beginner friendly. So if you're just coming from other discipline, you're trying to visualize some geospatial data set, LeafMap might be something that you want to try out because you just need a couple lines of code or no coding, and you can use the data set. You can add something like, for example, marker cluster. So if you have a CSV file, and then your CSV has 2 columns, longitude, latitude for certain location of your field work or location that you visited, you can just open the CSV and then change what kind of a column you want to display on the map, and no coding. Boom, the data will be displayed on the map with some nice marker, all built on top of IPyLeafLab. You can also download OpenStreetMap data. So for example, if you're interested in some specific area and you were trying to find the data, sometimes if you're not aware, you might go like everywhere trying to download the data. Where can I download the data? So now use LeafMap. You just need one line of code. Basically, for any location, you can retrieve data from OpenStreetMap, and it will directly load the data to the map. You can also save or export the data to your computer as a Shapefile or GeoJSON or any GeoPandas package. So as you can see here, you get tons of data. So either it's surface water, buildings, or any kind of a point of interest, you can directly download that using LeafMap, just one line of code. And if you have some data stored in your database, for example, in PostGIS database, you can also read the data from your PostGIS database and then load it to LeafMap, just within a couple lines of code. So it save you a lot of time. And you can visualize data interactively. So on the right here shows you, for example, this is the building data for New York City, right? So you can have polygon, you can have street lines, all kind of data, and you'll be able to visualize that easily. If you're trying to do this from scratch, this might take you hundreds of lines of code actually to do this. But now everything is interactive directly within LeafLab without much coding. If you want to visualize the changes, you might want to use the split panel map. So this gives you just one line of code. You can pass in the data layer you want, and then you can visualize it easy. So this would be particularly useful if you're trying to visualize, for example, urban growth or natural disaster before and after. So give you a quick, easy way that you can visualize the changes using LeafMap without coding. Okay. Besides the split panel map, you can also have multiple. So for example, this is also, you can link the map together. So you can have multiple maps on the same view, and then you can zoom in, you can zoom up. It's synchronized. So also you can visualize, for example, land use, land cover, right? So from 2001 to 2016, and just one line of code. You can do this very easy in LeafMap. And lastly, I'm going to show you here, you can also use the white box tools. I'm going to get into white box tools shortly, but this gives you an idea that you can access the geoprocessing power of LeafMap and also white box tools directly within the map. So you just need to click the toolbar and then click the toolbox. Yeah, you see here, everything is already integrated into the map. So you can click any tool you want, and then you just click the two parameters to provide the file, and then all you need to just click one. You can do this easily directly within the map, and you can load the data, the result back onto the map. So no coding. So you can do geospatial analysis directly within the browser without having to rely anything. If you can use Google Colab, you can use Binder, right? So you don't need to install anything. You can also directly open data from the internet, so you don't have to download data to a computer. So, but you can visualize the data set, you can process the data set directly within the map interface without having to write code. So this would be nice for people that with limited coding skills. But if you're an advanced user, you might still find this one useful if you just want to rely on the browser, you don't want to use any desktop GS software. Okay, so that's all about LeafMap. As I mentioned, Whitebox Tools is a very powerful geospatial analysis platform, and it's developed by Professor John Lindsay in Canada, University of Guelph. So you can take a look at the new website, Whitebox Geo, and also the user manual, GitHub, Twitter, YouTube. He posted a lot of very amazing posts, pretty much very often, weekly, and I would highly recommend that you follow his Twitter or his LinkedIn, and there are a lot of very interesting stuff. Right now, it has 470 tools, and the code is open source, so you can look at the source code behind each tool. It was developed using Rust language, so very, very fast and powerful. It supports a lot of front end. So Whitebox Tools is a command line program, and it has API, for example, Python. You can build on top of the command line program to provide some user interface. So highly recommend you check it out. The first one here I'm going to introduce is the Python front end. So you can install the package. The name is called Whitebox. And on the right here is the Whitebox one that comes with Whitebox Tools. And you can use the interface if you don't want to do coding, but you can write some very simple script to do geoprocessing easily, just using the Whitebox Python package. Very easy to install, so you can check out the link on GitHub. And so besides the Python, I also developed the Jupyter. So this one will make things a lot easier, and this is similar to the one I introduced earlier in the LeafMap, right? So everything is just depends on the Whitebox GUI, so you can run this one directly within the browser. Go to the URL, and then you'll be able to click the link to run things using Google Colab or using Binder. And again, just need a browser. That's it. You can do that on your local computer. You can do it on your laptop or even your cell phone, if you want. And very easy to do, super fast. And the Whitebox tool is amazing. So if you're looking for some geospatial analysis tools that without having to install a huge package, Whitebox Tools is for you. It's the package itself is less than 10 megabytes. So think about that, 10 megabyte. It's just a tiny one compared to, for example, QGIS or ArcGIS that are many hundred megabyte or gigabyte. And besides the Jupyter, I also developed the R front end. So if you're an R user, you can also use Whitebox Tools. Again, all the functions you can directly use within RStudio or R package. So you can directly call the function. Also, you can also run it in Google Colab. Again, check out the link to the GitHub webpage. And so this is the last one I developed. So the ArcGIS toolbox. So you can support ArcGIS Pro and also ArcMap, I think 10.6 and later. So you're welcome to check out this one. And basically, all these interactive components behind the scene is using the Whitebox Tools, the back end. So these are all called the front end. It's just basically the interactive GUI. But when you are doing the computation, it's still using the command line program. But many of you might not be comfortable using command line. So that's why I'm gonna build on top of the command line program to provide easy and interactive GUI for you to utilize our Whitebox. And lastly, there's also a QGIS plugin. So if you don't want to use ArcGIS, but keep in mind, I don't develop the QGIS plugin. So, but you can check out the link here. And this is kind of an interface. You can see it on the right here. Show you some of the tools. So you have access to all the 470 tools within the Whitebox tools. And so I have introduced GMap, LeafMap, and also Whitebox. If you have any questions, you are welcome to ask questions on GitHub. So for GMap and LeafMap, you can ask on my GitHub using the GitHub discussion. If you have any question about the Whitebox tools or the front end, you can use GitHub, or you can also post questions on the Google group. You're also welcome to follow my YouTube channel and leave comments on the videos. If you have any question, you can also follow my Twitter and LinkedIn, where I post updates pretty much daily. So if you want to follow the latest feature about GMap, LeafMap, or Whitebox tools front ends, you can follow me there. And lastly, if you really want to learn more, I also provide a couple more resources that you can learn. The first one here is geographic software design. So this is a course that I taught here at the University of Tennessee last semester. So, but I released all the video to YouTube. You're welcome to check out. It has 38 videos and more than 18 hours. So this course teaches you how to develop Python packages. For example, how I develop GMap, and teach you all the tools or practical skills that you need to know if you want to develop some open source packages. So if you want, check it out. I also have the other one, spatial data management with Google's Engine. So 20 videos, more than 10 hours, and give you some basic introduction to Google's Engine. So this is different from the GMap tutorial. So the GMap tutorial mostly just introduce the key features of GMap, but this course basically introduces more the basic concepts about Google's Engine, but it's in Python, so it's not JavaScript. And lastly, this is the course for PostGIS. So if you're interested in using GIS database, you might want to look into PostGIS. And so 12 videos, more than 5 hours. Check it out if you want. And so those are the courses that I provide, but I'm still trying to post videos weekly. So if you want to see more, learn more about the things that I'm working on, welcome to follow my YouTube channel. And yeah, so that's all for my presentation. And thank you very much for your attention. It's just an overview, so I went through very, very quickly, but you can always come back to for the PowerPoint for reference if you need to learn more, and you're welcome to reach out to me if you have any questions. I just want to give you something that, okay, give you an idea, what can this be helpful for my research or for my teaching. You're welcome to adapt my resources. Everything is open source, so you're welcome to adapt and then to suit your needs. But hopefully you will find it useful. It's free, open source, and everything runs just within the browser. So I will be happy to hear your feedback or your implication how you use these packages.
Awesome.
Okay, thank you very much.
Thank you, Dr. Wu. I think this was an amazing